Hello and welcome to Crazy Math Productions. Today we're going to be continuing our unit on solving systems of linear equations. And what we're going to be looking at today, we're doing, remember first we had looked at solving using the graphic method, and then we looked at using two different algebraic methods for solving. The first one was solving by substitution. Now we're going to look at what's called linear combination. So this is another algebraic form of solving linear systems. Again, we're trying to find a solution to the system, something that's going to be true when you plug it into both equations. Now to start us off, I'd like to do a little bit of a game. We've got two different numbers, a red number and a blue number. And what I'd like to do is I'd like to multiply this by something, the red number, and multiply the blue number by something. And what I'd like to end up with is opposites. For example, -3, +3, or +7, -7. Something so that I have these opposites on the same distance from 0 on the number line, but on opposite sides. Now, I could always just multiply them by each other. Multiply this one by 12 and this one by 4, and then make one of them negative, say that one. So we get -48. Or +48. There we go. We have opposites. I could do that, but the thing is, let me show you a little trick. If I put 4 and 12 inside what we'll call the magic box, try to find the least common multiple here. What can I pull out of both? What can I divide into both 4 and 12? I can divide a 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. So what I could do is, if you notice the 4 and the 12, I'm going to multiply everything by, find the least common denominator here. 4 times 1 is 1 times 3 is 12, so my least common denominator is 12. And what you noticed is, to get that 12, I can simply make an x here. 12 I could multiply by 1. 12 I could multiply by 1, and 4 I could multiply by 3. So 3 times 4, 12. 1 times 12, 12. And here I have the exact same number. I don't want the exact same number. I'd like one of them to be negative. Doesn't matter which one. Maybe we could choose this one. So that makes it a -12. So you notice we could just multiply them by each other. -12 gives me -48. Multiplied by 4 gives me a +48. Or I could find the least common denominator and realize I could just multiply by 3 and by -1 to get the results that I'm looking for. It doesn't matter. You get to choose, and that's the nice thing, that there are many options with linear combinations. Now, let me do it both ways here as well. First option is to simply multiply them by each other. So -6 times -3, -3 times -6, I get +18, +18. Now, that's not what I want. I want one of them to be negative. It doesn't matter. So I'm going to remove the negative from this and multiply by just a +6. 6 times -3 is -18. Now I have my opposites. But I could also get a little more in depth. Let's see, 6 and 3. 3 goes into both of them. 6 divided by 3, 2. 3 divided by 3, 1. Multiply all these together. 3 times 2 is 6, times 1 is still 6. And just cross here to see what I will multiply by. Multiply 6 by 1. Multiply 3 by 2. So I get -6, and -6 here as well. Now, both of these are negative. I don't want that. So I'm going to make one of them, one of the products that I'm multiplying the factors negative. So -1 times -6 is a +6. Now I have opposites. So you can see either way will work. And it just depends on the situation as to which one you would want to do. Okay, 6 and -4. Let's see, I could just multiply by 4. Multiply this by 6. Get 24 and -24. And that works out great. I immediately have opposites. Or 6 and 4 in a little magic box here. Find the least common denominator. 2 goes into both 6 and 4. 6 divided by 2 is 3. 4 divided by 2 is 2. And let's see, 2 times 3 is 6, times 2 is 12, so my least common denominator is 12. How can I get to 12? Well, I can multiply the 6 by 2 and the 4 by 3. 6 times 2, 4 by 3. 2 times 6 is 12. 3 times 4 is 12, but again, 3 positive times negative is negative. And I get opposites there as well. Okay, one more practice round. I can multiply the 8 by 10 and the 10 by 8. I get 80 and 80. But I want one of them to be negative. Let's just make this one negative. So negative times positive is negative. So I get negative 80 and positive 80. Now notice that gives me pretty large numbers. If I want some smaller numbers to deal with, let's see, 2 goes into both 8 and 10. Nothing goes into 4 and 5 besides just the number 1, so I'm just going to go ahead and multiply these. 2 times 4 is 8, times 5 is 40. So what goes into, what can I do to get 40 here? Well, I'm going to multiply the 8 by 5, multiply the 10 by 4. Gives me 40 and 40, multiplying. But again, I want opposites, so let's make this one negative. So negative 40, positive 40. You may be wondering, why in the world have we been doing this? Well, the reason we've been doing this has to do very much with the system of linear combination. You have instructions here on your sheet, but I'm just going to jump right on in. Number 1, first of all, I'm going to rewrite them with a little bit of color. Now what I'm looking for is to try to get opposites with either the x's or the y's. Now to start off with, we already have opposites. If you look here, we have a positive 3 and a negative 3. So this is very convenient. Now, we had spent much time trying to find these opposites earlier. Why in the world did we do that? Well, the reason is that we're going to add these up. So I'm literally going to add the top to the bottom. 4x plus 2x is 6x. 3y minus 3y is 0y. 1 plus 5 is 6. And so we combine these together, and that leaves me with one variable. Well, if I have one variable, I can just go ahead and solve for x. Let's divide by 6. X equals 1. Well, that's fantastic. All I need to do now is to pick one of the two equations. Doesn't matter which one. I think they're about equally easy to work with. So I'm just going to choose the red one. I'm going to plug x into the red equation. And let's see what happens. This is 4 plus 3y equals 1. We're going to subtract 4 from both sides. 3y equals negative 3. Divide by 3, and y equals negative 1. So there we go. We're done. Now, why did we get this? Well, x and y, if you plug those into both the red and the blue, it will make both of them true at the same time, and that's what we call a solution to the system. Let's keep moving. If you feel comfortable enough, feel free to pause the video and try it on your own. Let's see how you did. Now let's do some investigation. The game that we had played earlier, where we have the two numbers, what's happening is you're going to be playing that game either with the x's or the y's. So let's investigate and see which one is going to be easier to deal with. We could do it with the x's, multiply one by 2, the other one by 5, or actually negative 1 by positive. Or actually, you know what I could do? I could just multiply this bottom line by 3, and I'll have a positive 3 and a negative 3. That seems to be a little easier. So that's what I'm going to do. I'm just going to multiply the bottom. Let's see. I would get a positive 3 on top by just leaving it alone. If I multiply this by a positive 3, I should get a negative 3 on the bottom, and that will give me the opposites that I want. So 3 times 5 is 15x. Negative 1 times 3 is negative 3y. 3 times 11 is 33. And now you notice we have opposites. That's good. Now I can add these two together. 2x plus 15x is 17x. 3y minus 3y is 0y. 18 plus 33 is 51. And I can simply solve this equation and see what my solution is, or at least the x-coordinate of the solution. So x equals 3. I found half of the solution. Now all I have to do is plug it back in. It looks like either one's going to be easy enough to work with. Let's try the red one. So plug x into the red equation. 2 times 3 plus 3y equals 18. 2 times 3 is 6. We're going to subtract 6 from both sides. Again, we're solving for y because we already have x. We would like to know what y is. 3y equals 12. We're going to divide by 3. Y equals 4. And there we have it. Okay. Again, I would strongly encourage you, go ahead and see if you can do this on your own. Let's see how you did. Okay, so 2x plus 3y equals 0. 3x plus y equals negative 7. Okay, let's do some investigating. We're going to be doing a little game with either the x's or the y's. Let's look at the x's. It wouldn't be too bad to work with the x's, but it looks like it's going to be very easy to work with the y's. I don't have to multiply both lines, I just have to multiply one line. I'm going to multiply this bottom line by negative 3 so that I can get positive 3 and a negative 3. So let's do that. So 2x plus 3y equals 0. I'll just simply bring it down. Negative 3 times 3 is negative 9. Now you could put a 1 there. Negative 3 times 1 is negative 3y. Negative 3 times negative 7 is positive 21. Okay. Now we're just going to simply add these together. 2 plus negative 9 is negative 7x. 3y plus negative 3y is 0. 21 plus 0 is 21. So now I just have to solve for x. Okay, so I know that negative 3 is the x-coordinate of the solution. All I have to do now is to plug it back in and find out what y is. Now it looks like probably the blue is going to be a little easier to me, but of course you could choose the red if you like. Let's plug it back into the blue. 3 times, instead of putting x, we're going to put the negative 3. That's negative 9 plus y equals negative 7. We're just going to add the opposite. We get y equals 2. So plug that back in, and there's my solution. Now, as always, you could go ahead and try to make this video as short as I can. But if you wanted to in your own time, you could plug this back in, plug in negative 3 for x and 2 for y, and it should make a true statement for both of these for it to be a solution of the system. Okay, we're far along enough now that you should be able to do number 4 on your own. So please stop the video and try it on your own. Let's see how you did. First, I'm going to rewrite. Okay. Now, in most of the previous examples, it's been fairly obvious which one it's going to be easier to solve for. Now we're getting into some territory where it's really your choice. Doesn't matter. Now for the x, that looks like it's easy enough to solve for. Multiply 1 by 2, 1 by 3. Y could be easy enough to solve for. Multiply this line by 5, this one by 2. Of course, one would have to be negative. You know what? It really doesn't matter, so I'm just going to choose to solve for x. So I'm going to write a little note to myself here. Solve for x. And that's just to try to eliminate any confusion I might have. Okay, so we're going to have to multiply both lines by something. So I'm going to multiply the top line. I don't think I need to find a least common denominator. They're pretty small numbers. So I'm going to multiply the top line by 2 and the bottom line by 3. So I'm going to get 6x on the top and 6x on the bottom. The only problem is that I'd like one of these to be a negative because we want opposites. Positive negative 3, positive negative 3, positive negative 3. Wow, that's very interesting. So I'd like to have opposites. So I'm going to make the top one negative. You can make the bottom one negative if you like. Negative 2 times 3 would be negative 6x. Negative 2 times 2 would be negative 4y. Negative 2 times 10 would be negative 20. And on the bottom, 3 times 2, 6x. 3 times 5, 15y. 3 times 3, positive 9. All right, so we're going to add these up now that we have these opposites. Negative 6x plus positive 6x is 0. 15y plus negative 4y is 11y. Negative 20 plus 9 is negative 11. And now we divide by 11. So y equals negative 1. So I found part of my solution to the system. And now I need to find the other part. I need to find the x. So I'm just going to pick one of the two. It doesn't really matter. I'll just use red. So 3x plus 2 times negative 1 equals 10. So I'm using this top line here and plugging in the y. 3x plus negative 2 equals 10. So first distribute. Nope. Then combine all of your like terms. No. Please remember key change or you'll get burned. Nope. Then get all your variables on the same side. What are is? First addition or subtraction. Then multiply, divide. And so we find that x is 4. And that's my solution. Again, I would advise plugging it back in to both of the equations and making sure that's true. But for the sake of time on the video, we will hold off on that for the moment. Okay, 4 more examples. And that should be it. By this point, we should be fairly comfortable. So I'd encourage you to stop the video and try it on your own. Let's see how you did. I'm going to rewrite both of these. Now let's investigate. The x looks like it's easy enough to solve for. Multiply top one by 5, bottom by 2. You know what? The y's, though, I can multiply top by 4, bottom by 3, but it already has the negative taken into account. I think I'm just going to solve for the y's. Now, could you solve for the x's? Of course you could. You would just need to make sure that one of them will be multiplied by a negative number. So I'm going to solve for y. I'm going to make a quick little note for myself. Solve for y. And now we're going to get started. I'm going to multiply the top by 4. Multiply the bottom by 3. So 4 times 2x is 8x. 4 times 3 is 12y. 4 times 1 is 4. 3 times 5x is 15x. 3 times 4 is 12y. 3 times 14, well, 3 times 10 is 30. 3 times 4 is 12, so 30 plus 12 is 42. And now I'm in a position where I have opposites for the y there, so I'm just going to add these up. 8x plus 15x is going to be 23x. 12y minus 12y is 0. 42 plus 4 is 46. And now just solve for x. Divide both sides by 23, and x equals 2. So I know that part of my solution set is 2. I found half of it. But I need to find the full solution set. So I'm going to go ahead and plug back in. Looks like red is easy enough to work with, so I'll plug in 2 for x in the red equation. 2 times 2 is 4. And now we're just going to solve. So first distribute. Nope. Then combine all of your like terms. No. Please remember key change, or you'll get burned. Nope. Then get all your variables onto the same side. Well, they already are. First addition or subtraction. Then multiply, divide. And there we have it. So that's my full solution set. Again, I would advise you to go ahead and plug that back in, but we're going to go ahead and continue. Go ahead, try number 6. You might be a little confused, but go ahead and give it a shot, and then when you get to a stopping point, go ahead and turn the video back on. Okay, let's see what was the confusing part here. Now, I'm going to go ahead and rewrite. 3x plus 2y equals 2. 6x plus 4y equals 14. All right, as we do our investigation, looks like it would be fairly simple to do the x's here. Same thing for the y's, so it doesn't really matter. Let's just work with the x's. I'm going to say solve for x, just to remind myself. So what I'm going to do is to multiply the top line. If you notice, if we find the least common multiple, which you don't have to do, but it'll certainly make things easier. 3 pulls it out of both of these, divides into both of these. 6 divided by 3 is 2. 3 divided by 3 is 1. Multiply all these. The least common denominator is going to be 3 times 2 is 6, times 1 is 6. So I can multiply the 6 by 1 and the 3 by 2, and that's exactly what I'm going to do. If you just simply multiply these by each other, you would have you would have a denominator of 18 instead of 6, so you'd have much larger numbers. And with those larger numbers comes a greater chance that you would have some kind of careless error sometime. All right, so multiply the 6 by 1 and the 3 by 2. Now, that's not going to give me opposites. I need to have opposites. So I'm going to put a negative on the top, and we'll go ahead and proceed. Negative 2 times 3, negative 6. Negative 2 times 2, negative 4. And negative 2 times 2 is negative 4 as well. On the bottom, 1 times anything is itself, so just copy the line down. All right, and we have opposites, so let's add them up. Negative 6x plus 6x is 0. Negative 4y plus 4y is also 0. Interesting. And 14 plus negative 4 is 10. Now, this is probably where you were when you stopped the video. You may not have gotten these exact numbers, but you got the same idea. All of the variables added away, and we had 0 equals something that's definitely not 0. Now, if you go back and think about it, graphically, what would this mean? Well, this is describing a situation graphically where the two lines are parallel. What it's trying to tell you algebraically is that there are no variables, so there's nothing that I can put in here. But this is a false statement. And in fact, since I cannot plug anything into the variables, this will always be a false statement. There's no choice. So how do I write that? I say there is no real solution. And there we go. Let's try number 7. Again, I would encourage you to pause the video and try it on your own. Again, this one may be a little confusing, but hopefully you can get it. Let's see how you did. All right, so I'm going to rewrite these. Now let's do some investigation. I could work with the x's. What looks like it would be easy enough. The y's, easy enough, so it doesn't really matter. Again, I think I'll just go for the x's just to be consistent. So I'm going to just write a note to myself, solve for x. And let's solve for x. I need to, let's see, it looks like there's a common denominator here somewhere. So I'm going to do 3 and 6. Let's see, 3 goes into both 3 and 6. So 3 divided by 3 is 1. 6 divided by 3 is 2. Multiply these, we're going to get a least common denominator of 6. So multiply the 3 by 2 and the 6 by 1. So the 6 here I multiply by 1. A 3 I multiply by 2. Now this one's already opposite. This one, well, I shouldn't say that. This is a different sign. This is negative and this is positive. So we should end up with the opposites without having to multiply by a negative. So let's go ahead and do the multiplication here. Okay. Now, as I multiply this, I found that we have opposites here, so we can go ahead and add. 6x plus negative 6x is 0. Negative 4y plus 4y is 0 as well, so we can't put nothing there. Well, I guess in a way we are, but put 0. And then 6 plus negative 6 is 0. Now, think about the last situation that we had. It was fairly similar. There were no variables, and it was a false statement. So no matter what happened, I was going to get a false statement, always. Now, sort of the converse here. There are no variables, and it's a true statement. So no matter whatever you put into x and y, you're going to get a true statement. So whereas the last time we had parallel lines, this time we have a situation where it's actually a line on top of itself. It is just the same line. Well, how many are there points shared in common? There's an infinite number. There's one here, and there, and there, and there, and so on. So there are infinitely many solutions. Could you just say infinity? Well, not really. See, infinity is a number in and of itself. We're saying that infinity is a solution, but there's also other solutions. This is saying there's infinitely many. Infinity is one solution, whereas here we're saying there's an infinite number of solutions, including infinity. So a slight difference there. Make sure you use that terminology in answering that kind of a situation. Okay, and one last one. And you notice the only difference here is that it's not in standard form. So we'll need to put it in standard form and then proceed as normal. Let's go ahead and pause the video, try it on your own. All right, let's see how you did. I'm going to add 2x to both sides. Here I'm simply going to add 8 to both sides. And now I can proceed as normal. Let's investigate which one I want to solve for, x or y. X looks pretty easy. I could just multiply this by 2 and have the same number there. Here I'm going to have to multiply both of the equations. So I'm going to stick with the x. It looks like it's going to be a little easier. So I'm going to pull a note myself, solve for x, just to remind myself. Now let's get started. All I have to do is multiply this line by 2, and I'm going to get a positive 4x and a positive 4x. Well, that really won't do. I need opposites. So let's multiply, instead of by a positive 2, let's multiply by a negative 2. Distribute it, of course. So we'll get negative 4x plus negative 10y equals 44. All right. So let's add these now that we have opposites here for x. Negative 4x plus 4x is 0. Negative 10y plus negative 3y is negative 13y. And 8 plus 44 is going to be 52. So let's just go ahead and solve. Divide by negative 13. Y equals negative 4. And let's plug this back in. It doesn't seem to be any significant difference in difficulty, so I'm just going to choose the red one arbitrarily. Just pick it. Plug in negative 4 in for y on the red equation. And now let's solve. First distribute. Nope. Then combine all of your like terms. Again, no. Please remember key change, or you will get burned. Doesn't seem to be any of that there. Then get all your variables onto the same side, which they already are. First addition or subtraction, so we'll add the opposite. Then multiply, divide. And that completes my solution set. Negative 1, negative 4 plus x and y. Thank you very much for watching Crazy Math Productions.